In this video, we will look at how you can either do a confidence interval for a difference in two means or a test for a difference in two means where we're treating them as being from independent samples. So what you will do is go up to Analyze and then Compare Means and then Independent Samples t-test. Even though it says test, this will also provide you with the confidence interval. So if you want either of those things, this is where you would go. So let's say we want to see if the number of hours of sleep that a student gets on a typical weeknight differs according to those who say they're a morning person and those who say they're not. When you put in the grouping variable, you'll notice that there's two question marks here. What you need to do is define the groups. So ahead of time, you'll want to look at that variable in SPSS. It's over here in this column, and notice that the groups are ones and twos. So click Define Groups and we'll enter ones and twos. Maybe it was Y's and N's for yes and no, then we would put Y's and N's. So we want to put whatever is actually coded in SPSS here. And then you'll just click OK. And you're provided this list of output. So I'll talk about what we're having in this output here. So for the yes group, we had 20 people. The no, there's 46. These are the two sample means, so 7 and 7.13. We can already see they don't look very different. These are the two standard deviations, so like our S1 and S2. Down here then is all the stuff we need to look at either the test or the confidence interval. The first thing that you want to look at in SPSS is whether or not you should be using this row that's called equal variances assumed, or whether you should be using the row that's equal variances not assumed. In order to determine which row to use, you can see there's a longer division line right here. You want to do Levine's test for equality of variances. This SIG column here that has a 0.813 is a test of a null of equal variances and an alternative of non-equal variances. With a large p-value of 0.813, we would fail to reject the null, and so we would say the variances are equal, or we don't have evidence that they differ. So that tells me, with this p-value being large, that I want to work in this top row. Had this number here been less than 0.05, I would work in this bottom row. So looking over then in the top row, right after that division line, this t is our test stat. So we get a test statistic of negative 0.498 for the test of the equal means. Degrees of freedom 64, and then we have a two-tailed p-value of 0.62. So if you were doing a one-sided test, you would chop that in half because that is both tails. And then if you go a little farther in the output, way over here, we have a confidence interval for the difference. So you can see that we have negative 0.654 to 0.393, or an interval that contains 0, which would also suggest that there is no difference in the population mean amount of sleep that people get, whether they're a morning person or not. That 95%, if you want that to be a different amount, we can adjust that through the settings of this test. So if I go back to the independent samples t-test, there's an options button over here. And so if you change the options button, you can do a different size interval. So maybe I want 90%. If I rerun this now, I should get the same stuff that we just saw, but now I have a 90% confidence interval here instead.